Now we will introduce the Tukey's method used in randomized block design. As a recall, let's look at the example that we have in this section. So we would like to investigate the effect of three methods of soil preparation on the growth of seedlings. And each method is applied to seedling growing at each of the four locations, and the average first year growth is recorded. So here we have a location which cannot be changed easily by the researcher. So we call it as the block. And for soil preparations, it's basically designed by the researcher. Therefore, it is the factor in our experiment. And this factor has three levels, level A and B and C. And so in our notation, we use K to denote the number of labels or number of treatment in a factor. And we use little b to denote the number of blocks in our experiment. And we would like to know, is the average growth different for the three soil preparations? If we would like to see more explicitly that if a difference exists between the treatment means or block means, we can explore it using the confidence intervals method, or we can use the Tukey's methods in the previous session. Okay, so the idea of confidence interval are exactly the same as what we have in chapter 10. And Tukey's method is an advanced one that can reduce the type 1 inflation problems that we explained in section 10.3, where we explain the Tukey's method in more details. So now let's first see how do we derive the confidence interval for the difference between the treatment means. Now, the treatment means difference can have a distribution as a normal with mean, mu I minus mu j, and the variance. The variance is calculated by the variance formula. Therefore, you can see that it's 2 times sigma squared divided by b, because when calculating a treatment mean, you use b observations. Therefore, with this distribution, we can standardize the treatment means. Once you standardize the treatment means at t distribution, you can derive its interval estimate for the difference in treatment as the following formula. So now let's see how do we derive the confidence interval for the block means. So the block means again has the block means difference again has the normal distribution with mean, which is the population block means difference, and the variance 2 sigma squared divided by k. So the 2 comes from the variance formula that we are subtract 2 block means. And because each block mean contains, the calculation for each block mean contain k observations. So we have a denominator, which is k. And with this distribution, we can standardize the block means difference as a t distribution. Again, the degree of freedom for the t distribution is the error degree of freedom in the ANOVA table. So it is b minus 1 times k minus 1. So once we standardize the sample block means difference, we can find the interval estimate of the population block means, which is of the following formula here. So this is how we derive the confidence intervals, and which is actually the same following how we have it in chapter 10. And now we will go to the Turkey's method. So to find the Turkey's method, again, we also need to find a normalization using Tukey's idea to control the overall rate. So for treatment means, the normalization comes from the maximum and the minimum values. The range of the treatment means can be normalized by this formula. So, which is the Q denotes studentized range distribution with 2 degrees of freedom, because we have K treatment. So the first degree of freedom is K, and the second degree of freedom is the error degree of freedom, which the error degree of freedom is B minus 1 times K minus 1. So similarly, we have the same procedure for deriving the distribution for the range of block means. So the range of the block mean is B bar maximum minus B bar minimum, and we subtract it using the idea of Tukey's method. Therefore, we will divide it by S divided by K because when calculating a sample block mean, we use K observation. So the denominator here is in the denominator in the denominator is K. And it will be a Q or standardized range distribution where the first degree of freedom is B and the second is the error degree of freedom. So now let's summarize the Tukey's method. For comparing treatment means, the margin of error is omega, which is the critical value, times S divided by square root of B. And for comparing block means, the margin of error is the critical value times S divided by square root of K. So be careful that when you are calculating the critical value, the degree of freedom of comparing treatment means or block means are different. And for both cases, the set S is the square root of MSE, which can be seen from the ANOVA table, and the degree of freedom are both error degree of freedom, which is B minus 1 times K minus 1. And if any pair of means differ by more than omega, they are declared different. So now let's go back to see our example. In our seedling problem, we have 3 treatments. The 3 different methods of soil preparations, and we have the treatment sum and the treatment means. So to work with the Tukey's method, we will again rank the treatment mean from smallest to largest, and then find the margin of error and compare if the pair difference are larger than the margin of error, and if they are, then they declare to be different. Okay, so now let's first find the margin of error. To find the margin of error, we will have to check the table first. So margin of error equals the critical value times this standard error of the treatment mean. Okay, so the critical value is calculated by working with table 11, the studentized range distribution, and the first degree of freedom is the number of treatment, which is 3. The second degree of freedom is degree of freedom of error, which is 3 times 1, 3 minus 1 times 4 times 1. Here is a typo, sorry for that. It's K minus 1 times B minus 1, so it's 2 times 3, it's 6. Okay, so we can find the critical value by checking K equals 3 and degree of freedom equals 6. And the critical value is 4.34. And the S can be found as the square root of MSE, and B is 4. So multiply these two values, we have the margin error, which is 2.98. Okay. So now the next step is to rank this treatment mean from smallest to largest. So the smallest one is the treatment C, which is burning, okay. And then the next one is no preparation, which is treatment A, and treatment B is fertilization. Okay, so now let's rank the sample means from smallest to the largest. And because the margin of error is 2.98, so we can compare the pairwise treatment difference and see if the difference is larger than the margin of error. So let's start with the first let's start with the first treatment means and the second largest treatment means. The difference 0.45, which is smaller than the margin of error, so there's no significant difference between population means C and A. And now let's see population means A and B, which is the second and largest treatment means. So their difference is 3.5, which is larger than the margin of error. So we conclude that there is a difference between population means A and B. And since population means A and B are different, then when we calculate the treatment means between C and B, the difference is 4, which is again larger than the margin of error. So we will also conclude that there is a difference between the population means C and B. Great. So this is everything for this session. And I will stop here and I will see you in the next session.